Hey everybody, this is Mr. Beckstrom, and today we're going to be taking a look at section 3.4. This is the product and quotient rules. Now, both of these rules we're going to go over and look at least a couple of examples for each. These are also very important to make sure that you get down and that you can do these pretty quickly. The one example we did from the last section where we had a binomial times a binomial, and we ended up foiling that out, and then doing each term individually. This rule here will give us an alternative method for doing that kind of product. So let's take a look at the rule, and then we'll talk about how to use this going forward here. So it says that if we're going to take the derivative of two functions, let's say we call one of them f of x and g of x, and both of them are differentiable at x, then that's going to be equal to the derivative of the first function here times the second function plus the first function times the derivative of the second function. Now, I'm going to do this slightly different just because I learned it a slightly different way, but just remember addition and multiplication are both commutative, so it doesn't matter which one that you do first here, it doesn't matter which one you do first here, and you can swap those two terms around too if you like. But I remember it like this, that the derivative is the first times the derivative of the second plus the second times the derivative of the first. And remember, this is just a little shorthand notation. It helps me out because it helps me make sure I keep things in order. And then I can write the first function down. I can say f of x is equal to something here, and then I have g of x is equal to something here, and then I can take the derivative of both of those and then plug it all into here. And that's what we're going to do right now. So hold on just a moment. Alright, so here's the first example here, and if we were doing this from last section, we could have just distributed this 3x to the fourth with these two values here, and we could have just used the power rule with the constant rule on each one of those, breaking it up through the sum rule there. However, we want to use this formula now, so we have to define this as a product between two functions. And the only way I can see to break this up into two functions where we get every term here would be if we called this the first, and we called this one the second. Alright, so go ahead, see if you can set this up, pause the video, and then when you're ready for the solution, go ahead and unpause the video. Alright, so the first, I'm just going to leave that as f is equal to 3x to the fourth. And I'm also going to need the first derivative in there. You can see it right there. So f prime is equal to, remember I'm just using the power rule here with that constant rule. So this is going to be, you bring the 4 out front. 4 times 3 is 12. X, you subtract 1 from the exponent, and this is our derivative. All right, for the second term, that's going to be the 2x squared. 2x squared minus 1. And the derivative of the second term is going to be equal to, well, we can use the sum rule to break those up. So the first thing is just going to be 4x to the first, which is 4x, and then the minus 1 is a constant, so the derivative of that is just 0. So we're just going to have 4x. So now that I have everything broken up, I can put it into my little formula here. Now you're welcome to use this one. We're going to get an equivalent answer. But this is going to be 3x to the fourth times the derivative of the second. So times 4x. And then we're going to get a plus. And then we're going to get the second, which is 2x squared. So 2x squared minus 1. Be sure to put that in parentheses because we're probably going to have to distribute there, times the derivative of the first, which is 12x cubed, which is 12x cubed. And then it's simply about cleaning this up here. So this is going to 3 times 4 is 12. So this is going to be 12x raised to the 5th power plus, and I'm going to distribute this. So 2x squared times 12x cubed is 24x to the 5th. 4x raised to the 5th. And then minus 1 times 12x cubed is minus 12x cubed. And we can do a slightly more simplifying these two. Oops, I think I said 5th here and I wrote 3rd. Oops, let me fix that. All right. So these two terms will now combine. 36x to the 5th minus 12x cubed. And this is our solution. And if you wanted to pull a 12x cubed out of both of these, you could do that as well. And then I also wanted to point out one more thing. Let me just show you this. We could have done this slightly differently, although I think it would have been a little bit more work. But I could have pulled just the x4th and called that my first, and then the 2x squared minus 1, I could have called that my second, and then all I'm left with is a constant that's being multiplied. So I can pull the constant out, just do the derivative using this as my first, and then I could have multiplied that constant in at the end, and I would have gotten an equivalent, if not the same solution there. All right, let's take a look at another example. All right, so here we have e to the x times the cube root of x. So see what you can do, try to set it up, try to solve it, and then when you're ready to go through the solution, go ahead and unpause your video. All right, so here I think it's pretty obvious that we can break this up into the product of two functions. We'll call the first one e to the x, so that'll be our first one, and then our second one, the cube root of x, will be our second function there. And if I do it that way, I encapsulate the entire function, which is what I'm either trying to do or trying to get the entire function without a constant and use the constant rule to multiply back in at the end. Either way is fine, but here we don't have a constant to pull out. So the first function here is going to be e to the x, and the derivative of the first function is going to be, well, if we remember from the last section, the derivative of e to the x is just e to the x. The second function is the cube root of x, but I'm going to go ahead and write that as x to the 1/3. If you need a little refresher on how to convert roots to exponents, please let me know and I'll be happy to send you something. But you can also YouTube that pretty readily, and it's pretty easy. Let me go ahead and give you the formula. So if we have some x here raised to the a with the b root, then this is going to be equal to x to the a over b. So all you're doing is taking the b, pulling it around under the a, and removing the root, and these two things are equivalent. So in this case here, my b is 3, my a is just 1, because there's no power there, so it's assumed to be 1. So we take the 3, we pull it under the 1, and it becomes x to the 1/3 without the root. And then the derivative of this, which is going to be a little bit trickier, is going to be, pull the 1/3 out front, 1/3 x to the, and then you subtract 1 from 1/3, so that gives you negative 2/3. 2/3. Because 1/3 minus 1 is negative 2/3. All right, and this can really be written as, and you can do this now or later, but you can write that as 1/3x to the 2/3, right? Because we can pull that x to the 2/3 on the bottom to make it positive. and the 3 is already down there. So I'll probably leave it like this. So let's go ahead and now use our formula there. So it's the first term, e to the x, times the derivative of the second term. So that's going to be 1 over 3x to the 2/3 plus the second term, which is x to the 1/3, times the derivative of the first function, which is just e to the x. And let's go ahead and clean this up. And I'm going to go ahead and get e to the x all over 3x to the 2/3 plus x to the 1/3 e to the x. And if I wanted to, I could pull the e to the x out of both terms, but I am fine with just like this if we're talking about a test. This is good. The couple things that I want to do is I want to get all of the exponents positive, so if it's negative, pull it to the other side of the quotient line. And I also want to make sure that my denominators are rationalized, so I don't like square roots in the denominators, which technically this is, but this is okay right there. All right, let's take a look at the next rule. All right, here is the quotient rule. It's not quite used as much as the product rule is, but it is definitely something that we need to know. And a lot of times we're going to be able to rewrite a quotient as a product, and then we can just use the product rule because the quotient rule is a little bit more difficult, but we can't always do that. So we need to know how to do this. And my shorthand for this is the bottom times the derivative of the top minus, notice there's a minus there, the top times the derivative of the bottom all over the bottom squared. So this is how I write it, and unlike the last rule, this one is pretty much in the same form as this one here. So if we can write a function as a function on top divided by a function on the bottom, then as long as the bottom is not equal to 0, because we can't have a 0 in the denominator, we can find the derivative by doing this. A little bit more work than the product one, but sometimes essential. So let's go ahead and look at a couple of examples here. All right, so here's the first one, the function of x of 2e to the x minus 1 on top over 2e to the x plus 1 on the bottom. So go ahead, try to do this, and then we'll go through the solution. So unpause when you're ready. All right, so here I need to know what the bottom is, the derivative of the bottom, the top is the derivative of the top, and then here I still need to know the bottom. All right, so let's go ahead and do this. So let's start with the top. So, oops, don't have my pen on. So the top is equal to, that would be the function up here. So 2 e to the x minus 1. And I'm also going to have to know the derivative of that is equal to, so remember the derivative of e to the x is just e to the x, and using that the constant rule of pulling it out and back in, the derivative of that is just going to be 2e to the x, and then the minus 1 just becomes 0, so we don't need to put that on there. And then we have the bottom. All right, that one is equal to 2e to the x plus 1, x plus 1, and the derivative of the bottom, very similar to the top, is just going to end up being 2e to the x. Remember, we're using the derivative of e to the x, and then we're also using that constant rule of pulling it out and back in again. All right, so now that we have everything, let's go ahead and put it in this form here. So it's going to be the bottom, which is 2e to the x plus 1 times the derivative of the top, which is 2e to the x, minus the top, which is 2e to the x minus 1, all over the derivative of the bottom, which is 2e to the x, all over the bottom squared, which is going to be, just leave it like this, 2e to the x plus 1 quantity squared. And it's going to be quite a bit of cleanup here, so you want to distribute that and distribute that. Let's go ahead and work through this one here, just so get a little bit of practice here. So this first one is going to become 4, and that's going to be ex squared. And if I write this over here, that's going to be e to the x quantity squared. And remember, when you have an exponent to an exponent, you can just multiply those. So that's just e to the 2x. So whenever you square e to the x, it's just going to become e to the 2x. So that's e to the 2x, and then plus 2e to the x. And then here, we're going to have a minus, and then we're going to have a 4e to the 2x, because that's 2e to the x times 2e to the x, which is 4e to the 2x, and then you're going to have a minus and a minus. That's going to be a plus 2e to the x, 2e to the x, all over this thing here, 2e to the x plus 1 quantity squared, quantity squared. Now that is going to cancel out with that. So 2e to the x plus 2e to the x is just going to be 4e to the x. So on top, I should just have 4e to the x all over 2e to the x plus 1 quantity squared. And there's really no reason to multiply this out. You might say, well, if we FOIL it, we're going to get that 4e to the 2x. But that's not going to help us because we have a bunch of other terms down there. So usually we just leave it as squared, and sometimes we're able to actually factor 1 or 2 of those entire factors out. All right, so let's look at another example. All right, so now this one here is going to be a little bit trickier than normal. So go ahead, see how far you can get. We may have to use different rules here. But you give it a try and see what you can do. All right, unpause it when you're ready for me to go through it. All right, so it looks like right away that we can set this entire function up under the product rule, because I can treat this as my first function, and I can treat this as my second function, right? So, but when I am taking the derivative of those, it looks like I may have to use the quotient rule inside. So here's an example, and there's going to be lots of examples where we have to use more than one rule. But the idea in the beginning is to break this up into either a product or a quotient using everything. So I can break it up into a product using everything. I can't do that with the quotient, so I'm going to start with the product rule. So I'm going to call this the first and this the second. So the first one is equal to 1 plus 1 over x squared. And then I want to do the derivative of the first. And the 1 cancels out because that's a constant. So I'm just going to take the derivative of 1 over x squared. I'm going to do that off to the side over here. So what I'm going to do is do the bottom, which is x squared, times the derivative of the top, right? Which the derivative of 1 is just 0, minus the top, which is 1, times the derivative of the bottom, which is 2x, using the power rule, all over the bottom squared. So that's x squared squared. So really that's just x to the 4th power there. All right. This is using this and using that. So this is going to end up becoming negative 2x over x to the fourth. Right, because negative 1 times 2x is negative 2x. This zeroes out. And then I can pull an x out of both the top and the bottom. And I am going to get negative 2 over x cubed. Negative 2 over x cubed. Alright, so that's that one right there. Negative 2 over x cubed. And then I want to know the second one. So the second function there is x squared plus 1. And the derivative of that is just going to be equal to 2x. 2x, because the 1 will drop off. Alright, now that I have everything, remember I'm using the product rule. That's the first times the derivative of the second plus the second times the derivative of the first. Alright, so the first is going to be 1 plus 1 over x squared and times the derivative of the second, which is going to be 2x, plus the second, which is x squared plus 1, times the derivative of the first, which is negative 2 over x cubed. And then you're going to need to distribute those and simplify, make sure all your exponents are positive, and I will let you work on that one on your own. And finally, let's take a look at this example. So go ahead, try to set this up either as a product rule or as a quotient rule, and then we will go ahead and work that one out. So go ahead and do that now. When you're ready, unpause. Okay, so before I even start here, one thing that I want to notice is that it looks like I can probably make the top a little bit easier here, because it looks like I can factor out a t, and then I'll be able to cancel one out with the bottom. So this function is equal to, if I'm factoring out a t from the top, that's going to be t squared plus 3t plus 1, all over t squared, now I can set this up as a division, a quotient rule, and this is also a good candidate for a chain rule, which we're going to be looking at. I believe it's next section or in a couple of sections here. But for now, since we only know the quotient rule, let's use that. So we have the bottom, which is equal to t squared. We need to know the derivative of the bottom, which is equal to 2t. And then we need to know the top, which is equal to t squared plus 3t plus 1. And also the derivative of the top, which is equal to 2t plus 3. Alright. Alright, now that I know all this, I just need to put it in this formula here. So this is going to be the bottom, so t squared, times the derivative of the top, which is 2t plus 3, 2t plus 3, minus, and the top, which is t squared plus 3t plus 1, times the derivative of the bottom, which is just going to be 2t, all over the bottom squared. So that's going to be t to the 4th power. Alright, and then what we're going to end up doing is distributing all of this, cleaning it up, and giving a nice simplified answer. So once again, I will let you do that part, and if you have any questions with it, please let me know. And I hope everybody has a great rest of your week. Thanks.